Hi everyone, I'm Christina and welcome to the 7th video in our trigonometry series. Today we will be looking at exact trig values, which we will use to solve trigonometric equations, prove identities, and ensure we're not rounding if we're doing calculator-free questions. So the objectives of this video are to find exact trig values using the unit circle and special triangles, and to recall exact values for 0, pi over 3, pi over 4, pi over 6, and pi over 2. Those are all angles in radians. So first we're going to have a look at this table here in our figure 1, showing us the values of sine, cos, and tan theta for our angles, which are all in degrees in the top row here. So what we'd want to do first is to convert these into radians, and I have included that conversion down here. So we can see that radians is equal to the angle in degrees multiplied by pi over 180. And I'm going to leave it as a task to you to check that all of the values that I'm about to write are correct. So for 0 degrees, that's 0 radians. For 30 degrees, that's pi over 6 radians. For 45 degrees, that's pi over 4 radians. For 60 degrees, it's pi over 3. And for 90, it's pi over 2. Okay, now you are expected to recall all of these values in this table here. Now, 0 and 90, or 0 and pi over 2, are quite easy to remember if you look at the trig graphs in video 6. So that will help you consolidate these exact values. But the rest of these values, we're going to remember them using special triangles, okay? And just to understand where these special triangles are coming from, the special triangles come from the unit circle. Okay, so we can form right-angled triangles inside the circle to give exact values. And you can see that here we have a circle of radius 1. We have a right-angled triangle formed within the circle. Our theta is x, and so we have one side as cos x and the other as sine x. And we did see that in our first video in our trigonometry series. So if we start with our first special triangle that we are looking at, it's the right-angled isosceles triangle with two equal sides of unit 1, where both angles are pi over 4. And the remaining side, the hypotenuse, is root 2, and you can verify that using Pythagoras very easily. So using this triangle, we want to recall our exact trig values for sine, cos, and tan of pi over 4. So how can we do that? Well, let's start with sine of pi over 4. So both of these angles are the same, so you can take either one as theta. So let's say we took this one here as theta. We know that sine of theta is equal to the opposite over hypotenuse. So if that is our theta, then our opposite side is equal to 1, because it's this side here. So that's our opposite over hypotenuse. Our hypotenuse is root 2. So it's just 1 over root 2. And that's our exact value of sine pi over 4. Okay, so now if we want cosine of pi over 4, remember from our equations, cos of theta is equal to the adjacent over hypotenuse. Well, the adjacent to our angle theta here is just 1. So we're going to write 1 there. Over our hypotenuse is just root 2. So sine of pi over 4 is equal to cos of pi over 4. They are both 1 over root 2. So now what about tan of pi over 4? You can use that tan theta is equal to opposite over adjacent. We can also use that tan theta is equal to sine theta over cos theta, both would be correct and they should both give you the same answer. So let's check that. If we're using the fact that tan theta is opposite over adjacent, this is our theta, opposite is 1, adjacent is 1, so that's just 1 over 1. It's 1. And then if we use that tan theta is sine theta over cos theta, well, that means that we're going to do sine of pi over 4, which is 1 over root 2, over cos of pi over 4, which is also 1 over root 2. And that's also 1. Okay? So that's our first special triangle there. And these values all correspond to the values given in our table in figure 1. So our next special triangle is our pi over 3 and pi over 6 right-angled triangle. So we have two different thetas here, and we want exact trig values for both. So it's our pi over 6, 30 degrees, and pi over 3, 60 degrees. So let's just start with our theta being pi over 3 initially. So we want sine of pi over 3. With pi over 3 is our theta, we know that sine is equal to opposite over hypotenuse. The opposite side is root 3. So we'll write root 3 over hypotenuse. Our hypotenuse is 2. So it's root 3 over 2. Do the same for cos. Cos pi over 3 is equal to adjacent over hypotenuse. If pi over 3 is our theta, the adjacent side is 1. So we need to write 1 over our hypotenuse, again, is just 2. It's 1 over 2. And do the same thing, tan pi over 3. Let's do tan pi over 3 is the same as sine pi over 3 over cos pi over 3. That's going to be equal to root 3. It's right here. Root 3 over 2 divided by 1 over 2. That's just root 3. Okay, so tan pi over 3 is root 3. So now let's take theta as pi over 6. So we're going to start writing the exact trig values for theta as pi over 6. So this time our opposite side is equal to 1 for sine, so opposite over hypotenuse. Our hypotenuse is still 2. So in fact, it's 1 over 2 sine pi over 6. Cos of pi over 6, our adjacent side to our theta equal to pi over 6 is actually root 3 over 2. Sorry, it's root 3. So root 3 is our adjacent, and our hypotenuse, again, is just 2. So it's root 3 over 2. And our tan of pi over 6, again, I'm just going to work it out as doing sine pi over 6 over cos pi over 6. So I can work that out quickly here. Sine pi over 6 over cos pi over 6. That's equal to 1 over 2 divided by root 3 over 2. And I'll just write the intermediary step here. 2 over root 3. And you can see that that's equal to 1 over root 3. Okay, so in the next video, we're going to have a look at our graphs again, and I'm going to help you to sketch them.